So when a user asks any question to LLM, we know the LLM has been trained with some publicly available data, right? So the LLM can answer with its generic intelligence. Otherwise, if the LLM cannot answer with its generic intelligence, then we need to train this LLM with your organization's domain specific data by loading your documents using document loaders and then chunk the document. We have already learned different chunking methods in the previous lectures, right? And then we have seen how to create embeddings for these chunks, right? Because the LLM cannot understand text and it can only understand numbers, right? And then we have seen how to store these embeddings inside a vector database and provide access to this vector database to the LLM so the LLM can answer for any domain specific user question, right? And this process is called RAG, Retrieval Augmented Generation. And we have seen this already, right? And then we have seen different prompt engineering techniques, that is how to ask a right question to get the right answer from the LLM, right? And then we have seen how to provide memory to an LLM so it can remember the context for any sequential questions, right? And tools and agents we will cover in the upcoming lectures. And now let's see chains, right? So what is a chain? We know LLM can do a single task, right? And chain is a wrapper. So by using chain, LLM can do different complex tasks together, right? So you can use just an LLM alone for simple applications, right? But for more complex applications, we need chaining LLMs, that is either with each other or with other components. We need to chain in order to build complex applications, right? So LangChain provides chain interface to build complex chained applications, right? And we define a chain as a sequence of calls to components, which can include other chains as well. So the objective of chain is it will make complex tasks simpler. That is, a chain can do a few simple tasks together. And we have several built-in chains available inside LangChain, which we will go through. Okay. So chain will allow us to combine multiple components together to create a single coherent application, right? And LangChain has 4 foundational chain types: LLM chain, router chain, sequential chain, transform chain. So LLM chain is nothing but a simple chain with a prompt template and that can process multiple inputs, right? And router chain, it is a gateway that uses the large language model, that is LLM, to select the most suitable processing chain. So depending on your input, it will try to route accordingly, right? And sequential chain, that is a family of chains which processes input in a sequential manner. That means the output of the first chain will be passed as the input to the second chain, and the output of the second chain will be passed as the input to the third chain, right? And so on. And transform chain, this is used to apply data transformations or data processing. For example, let's say if you want to do string manipulation, right? So that's when we use this transform chain. And these chains provide core building blocks for constructing complex workflows with large language models, LLMs, and other tools as well, right? And in the upcoming lectures, we will see implementing different scenarios or projects by using these chains. So we will cover how to implement a single chain, simple sequential chain, sequential chain, MathChain, RAG chain, router chain, LLM router chain, SQL chain, and we will also see how to deep dive other different chain types depending on your requirements by going to the LangChain documentation. So we will cover how to implement different scenarios by using these different chain types. Alright, thank you. So far we learned about what is chain and what are the different types of chains available, right? So what is chain? Chain will allow us to combine multiple components together to create a single coherent application, right? And we have several chain types available, and we will see the implementation of these chain types one by one, right? The first one is single chain. So let's go to VS Code and see the implementation of single chain, right? So you can create a chain that takes user input, formats it with a prompt template, and we have already seen this in our prompt engineering demo already. So let me go to prompt engineering demo and let's try to open one of the prompt engineering type. So here you can see we have used LLM chain, right? And if you go to this basic chain, we are trying to bind both LLM and prompt together by using this LLM chain, right? So you can build more complex chains by combining multiple chains also together. So this chain is not new to you. We have already seen another chain, that is conversation chain, when we did our different types of memory implementations, right? For example, if you come here, we have seen conversation chain, right? So if you see this chain, we are trying to bind LLM with memory, right? So that is the advantage of using chain. So similar to conversation chain, we have several other chain types available. So now the first one is simple chain, right? So let me close these, and similar to how we have done before, I have created an empty folder which is called chains demo. So let's try to add this folder to our build generative AI applications workspace, right? So come to this explorer, right click, add folder to workspace, and select chains demo and add an S, right? So this is an empty folder, we do not have anything here, right? So let's try to create an Python file. So we are starting with a simple chain. So let's try to save this inside our chains demo, and let's save this as single chain demo and save it. And here we will be using OpenAI as our LLM. So let me try to create an environment file here, .env, where we can store our API key, right? I've already shown how to get the API key from OpenAI, right? So make sure you get your key and store it here. Store your API key here, okay? So once you store your API key here, first thing is let's try to install all the required packages and then import all the modules that are required, right? So make sure you install LangChain OpenAI. Whenever you get any message that the module is not found, then make sure you install the corresponding package by using pip install. So all you have to do is go to the terminal and then type here. For example, let's say if you do not have LangChain OpenAI package installed on your machine, then just type pip install LangChain OpenAI and hit enter. Then LangChain OpenAI package will be installed on your machine, right? I have already installed, so I'm not installing again. And then we are trying to load chat OpenAI from LangChain OpenAI, and then chart prompt template from LangChain prompts chat, and human message prompt templates again from LangChain prompts and chat. And this is to load the environment variable where we stored our API key, right? What we did so far, we have installed all the required packages and then we loaded our modules and save it. And the first thing is let's try to load the environment variables from .env file by using load_.env function, right? And then once we load the environment file, next thing is let's try to read the API key by using this OS module and use the getEnv function, and this is the name we have given inside our env file, right? So this is where we try to store our API key. So we are trying to read the API key and assign this to API_key. So once we read the API key, let's try to assign this API key to environment variable which is called OpenAI API key. So once we have the API key, if you notice here we have human message prompt template. So let's try to create a simple prompt by using this human message prompt template which is imported from LangChain prompts chat, right? So we are trying to create a simple prompt by using human message prompt template. and inside this we have a method called from template, and here you can pass the message. Make a funny company name for a company that produces this product, and this product is a dynamic variable, right? So instead of hard coding the value, we are just trying to use a dynamic variable, and we will pass the value to this variable when we invoke the method, right? So instead of hard coding the value, we are using a dynamic variable, right? So the next thing is we have chat prompt template, right? So let's try to create a chat prompt template by using this chat prompt template. So we have already created the prompt, which is nothing but human message prompt, and let's pass this to our chat prompt template, right? So we are using chat prompt template, which is inside LangChain prompts chat, and inside that we have a method called from messages, and we are passing this simple prompt, right? So we have the prompt ready. This chat prompt template has the prompt, that is the question that we will be asking to our LLM, which is nothing but OpenAI, right? So what we are trying to ask, make up a funny company for a company that produces the corresponding product. We will pass the product and it will give us the funny company name, right? So our prompt template is ready. So before we use our chain, we need an LLM, right? So now let's try to initialize our OpenAI LLM by using chat OpenAI, which is from LangChain OpenAI. So this is our chat prompt template. Next thing is let's initialize LLM. So we know we can initialize LLM by using this chat OpenAI, and I'm assigning to a variable called LLM. So we have our chat prompt template ready, and we also have our LLM ready. Now once we have both LLM and prompt template ready, so let's try to bind our LLM with this chat prompt template by using chain, right? Bind LLM and chat prompt template. So always remember, this pipeline is a representation of a chain. So here we are trying to bind LLM with the prompt template by using this chain, okay? And we are assigning to a variable called chain. So this is a single chain, right? So we have created the chain by binding LLM with the chat prompt template. So this chain is nothing but combining multiple components, and here the components are LLM with chat prompt template, okay? So once we have the chain ready, inside the chain we have a method called invoke, which we have already used in our previous implementations, right? So let's try to call the invoke method and pass the product name, right? So inside the chain we have the method called invoke, and for the input attribute we are trying to pass the topic name and call the content attribute and assign this to a variable called funny company name. So here we have to pass the value to this dynamic variable product, and we are passing by using input is equal to topic. So we have to initialize the variable by assigning the value to this, right? So for example, let's say the topic name is travel. So this travel will be passed here. So when we invoke, this travel name will be replaced here, and then it will try to give us a funny company name for a company that produces travel, right? Now let's try to see what we have inside this funny company name, and here you can replace this topic with any other product. Instead of travel, you can replace with any other product and see what is the funny company name that our LLM is trying to give us, right? So now let me try to print and see what we have inside the funny company name, right? So let's try to run the code. So you can see this is the funny company name for a company that produces travel, right? So Wanderlust RS, your one-stop shop for slightly off-centered adventures. So this is one of the funny company name, and let me just try to format this, right? Instead of just printing this way, let's just try to comment this. We've already seen this, so I'm commenting this as well. So what we are doing here, I'm just trying to bold it here. So this is a new line, /n is a new line, and this is just for making this text bold. I'm just giving this, and this is the topic, make a funny company name for the topic travel. So this will come as bold because we are giving this, and then I'm just trying to print 50 times this hyphen, and then this is we are trying to make it not bold, and then it will give the value of the funny company name, right? So let's try to kill this and then rerun the code. So now you can see make a funny company name for the topic travel, right? So this travel is passed here. So I'm just trying to bold it here, and then we are trying to print 50 times this, and then this is to make it not bold, and then we are trying to print the value funny company name. So this is the funny company name our LLM OpenAI is trying to give us, right? So let's say instead of travel, if you are interested in tennis, right? So let's replace this and rerun the code. So now you can see make a funny company name for the topic tennis, smash hits rocket go, right? This is the funny company name it has given us. And then now instead of tennis, let's replace this with chess, right? And let's rerun the code. So now you can see checkmate comedy chess go, where every move is a funny one, right? Or instead of chess, let's give dance and rerun the code. So for dance, this is the funny company name it has given us. So now you get the idea of how to use chain to bind one or more than one components together. You can bind multiple chains, or you can bind LLM with either template or memory, right? So you can try to bind LLM with multiple components by using this chain. So that is the objective of using chain. So what we have done here, we have installed all the required packages, that is LangChain OpenAI, by using pip install LangChain OpenAI, and then we have imported all the required modules. Here we are using these modules: chat OpenAI to chat with our OpenAI LLM, and then prompts. We have used chat prompt template to create this template, and also human message prompt template. And then by using this load_.env, here we have created the environment variable. Inside that we have stored up OpenAI API key. So we are trying to load that by using load_.env, and then we try to read the key, and we store this key inside our environment variable OpenAI API key, right? So let me close this. So once we have the key ready, next thing what we did, we tried to create a simple prompt by using this human message prompt template. Inside that we have a method called from template, and we passed our template. We're trying to make a funny company name for a company that produces this product, and this product we will be passing when we try to invoke the chain here, right? And then here we are trying to create a chat prompt template by using chat prompt template, which is inside LangChain prompts chat, and inside that we have a method called from messages, and we are passing this prompt, right? And then we got our chat prompt template. So we got the template ready. Next thing is LLM. This is how we can initialize our LLM, which is nothing but OpenAI, right? So inside LangChain OpenAI, we have this chat OpenAI. So by using that, we are trying to initialize our LLM. And once we have the LLM and the template ready, we are trying to bind our LLM with the chat prompt template by using this chain. So this pipeline is a representation of chain. So once we have the chain ready, inside chain, we have the method called invoke, and for input attribute, we are trying to pass the topic, which is nothing but our product, right? Dot content, and this will give us the funny company name, and we are trying to print it. So we are passing the product, and it will give us the funny company name, right? So the objective of chain is to bind LLM with any other component, right? It can be template or memory or any other component, right? So this is a single chain where we passed our product name, and it gave us a funny company name for that product. All right, thank you. So we have seen single chain. The next one is simple sequential chain. So let's go to VS Code and see how we can implement simple sequential chain. Okay, so this is our build generative AI workspace. So inside this we have created chains demo folder, and underneath we have single chain demo. So what we have done in single chain, we have used human message prompt template, and we created a simple prompt, and then we passed that to chart prompt template from messages, and we created the chart prompt template, and we initialized our LLM by using chat OpenAI And once we have the LLM and the chart prompt template ready, we try to bind LLM with the chart prompt template by using chains, right? And we have provided the topic, and the OpenAI tried to give us the funny company name, right? So here we try to call the invoke method and get the results, right? So this is single chain. Now let's try to see simple sequential chain. So let's go to chains demo, file, new file, Python file, and let's try to save this as simple sequential chain demo underneath chains demo folder, right? So save it. So the first thing is we have to install all the required packages by using pip install LangChain OpenAI. This is the package we need because we will be using the modules that are present inside LangChain to see simple sequential chain implementation, right? So make sure you install LangChain OpenAI package in case if you haven't installed already. We have used the same package here as well when we are implementing single chain, right? So now let's try to import all the required modules. So here we will be using OpenAI. So we are importing chart OpenAI to initialize our OpenAI LLM, and then chart prompt template to create a prompt, and then this is to load the environment variable, right? So inside our chains demo, we created an environment variable and we stored our OpenAI API key here. So let's try to load the environment variables from this environment file by using load_.env, right? So once we load the environment file, the next thing is read the API key by using getEnv function and pass the key name. So we will get the API key value, and we are storing inside this variable API_key. And now let's assign this API_key to an environment variable which is called OpenAI API key. So we installed all the required packages, we try to load the modules that are required, and then we try to load the environment variables from this environment file, and we read the key, and then we stored our OpenAI API key inside OpenAI API key environment variable, right? So what is sequential chain? Sequential chain means one after another, right? So that is the output of first chain will be passed as the input to the second chain, and the output of second chain will be passed as input to the third chain, right? So it will be executed one after another, right? So the next step is let's initialize our LLM by using this chart OpenAI, which is from LangChain OpenAI package, right? Let me close this. So we can initialize OpenAI LLM by using this chart OpenAI, which is inside LangChain OpenAI package, right? So once we initialize the LLM, the next thing is let's try to create a prompt template by using this chart prompt template. Again, this is from LangChain prompts, right? So the first thing is let's try to define a prompt template, and here we are creating a prompt template and assigning to a variable called template. Give me a simple bullet point outline for a blog post on the topic, right? So whatever topic we pass, it will try to give a simple bullet point outline, right? And now let's say the topic is travel, right? So let me define the topic as well. Here you can replace this travel with any other topic and see if the LLM is returning the bullet points for this topic or not, right? And this prompt is nothing but the question that we are asking to the OpenAI LLM, right? And here we are telling the LLM to create a blog post on the topic travel, right? That is, I will provide a topic and the LLM will provide me with a bullet point outline on that particular topic, right? So this is the task, and we already created the template, right? So now let's pass this template to chart prompt template and create our prompt. So we are using chart prompt template, which is inside LangChain prompts. Inside that we have a method called from template, and for this we are passing the prompt template which we have defined before, right? So this is how we created our prompt. Now once we have the prompt and also the LLM ready, the next thing is let's try to bind this LLM with this prompt by using chain, right? So let's try to create a chain. So we are trying to bind the LLM with the prompt by using this chain, right? So always remember this pipeline represents a chain, right? So this is single chain because we are trying to bind LLM with the prompt, right? So let's call it chain 1, right? So this is first prompt and this is chain 1. Now let me just try to print what we have inside this chain 1, right? So let's run the code and see if it is working so far. So you can see chain 1, we have the prompt template and we also have the LLM, right? This is the chat prompt template and the template that we are passing is this, and we also have the LLM details, right? So far we are good, right? So this is the first task. So we have provided the topic, which is nothing but travel, and we are asking our LLM to give us a simple bullet point outline for a blog post on the topic travel, right? So this is the first task, right? Now similarly, let's try to do another task, that is second chain or task, right? So first of all, why do we need a chain? To bind simple tasks together to create a complex task, right? Remember, chain is not an LLM, right? Chain is kind of a process that helps us to solve tasks by binding different components together, right? So let's try to create another prompt by using this chat prompt template, just like how we have done before. Let me copy the same code, and instead of this template, let's replace this with write a blog post using this outline, right? So when we invoke first chain, that will give us a blog post, right? And the output of the first chain we are passing as an input to our second chain, right? So for this outline, we are asking to write a blog post using this outline, right? So we don't have to define the topic again. And here we are trying to create the prompt. So let's name it second prompt. And again we are using chart prompt template and we are calling the function from template and we are passing this template, right? And then let's try to create chain 2, right? And bind the LLM with the second prompt, and this is our second chain, right? So what we did so far, this is our first task, right? We are passing the topic as travel and that will give us a bullet point outline for a blog post on travel. And once we get the bullet point outline, we are creating a second task. For this second task, whatever the output we get from the first chain execution, we will pass that as input to the second chain, and we are asking the LLM to write a blog post using the outline that we got from our first task. So far we have created 2 tasks. And now let's try to combine this chain 1 and chain 2 by using another chain. So full chain is equal to chain 1, and again we are trying to chain, right? So you can chain 2 chains together by using chain. So either you can bind LLM with a prompt or LLM with a memory, or we can also bind 2 chains by using chain, right? So here we are trying to bind 2 chains and we are assigning to full chain, right? So full chain will do 2 tasks together. That is, we created a complex task which is nothing but a full chain by combining 2 simple tasks. One is chain 1, the other one is chain 2, right? That is task 1. We will provide a topic and the LLM will provide us with a bullet point outline on that particular topic. And task 2 is we will be passing the outline, which is the output from chain 1, as an input to chain 2, and the LLM will give us the complete blog post, right? So the output of first chain is input to second chain and we will get the output, right? So here this ABC will be replaced with first chain output, which is nothing but the topic outline, right? So we will pass the topic and we will get the outline for a blog post, and that outline will be replaced here and we will get a blog post for that outline, right? Once we have the full chain ready, let's try to call the invoke method, right? So inside chain we have a method called invoke, and let's try to pass the topic as travel, right? So we got our result. Now let's try to print the result and see what we have inside this result variable, right? So here what we're trying to slash n means this is a new line, and this is, I'm just trying to bold this text, write a blog post using outline. I'm just trying to bold that text by using this, and then we are trying to just print 50 times this, right? And then this one to not make it bold, and inside the result we are just trying to get the value of content, right? So let's try to save this and run the code. So if you see here, we are trying to print chain 1 and chain 2, and here we are trying to get a blog post using the outline, right? That is our full task, and the topic is travel, right? So this is the blog post it has given us, right? So let me close this. So what we have done here, we created two tasks. The first one is this one, and then the second one is this, and then we try to combine these two tasks together by using another chain, and we try to invoke it, right? Let's say if you are confused, let's try to print just the output of chain 1, right? So let me comment this chain 1 and chain 2, and then chain 1 dot invoke and pass the topic, that is the input for chain 1, and we will get the chain 1 result, right? Let's try to print the value inside the result, right? Result dot content, and what we are trying to tell, for the first chain, give me a simple bullet point outline for a blog post, and we are passing the topic as the input, and we will get the result dot content, that will give us the first chain output, right? So this is our task 1, and whatever the value we get from task 1, that will be replaced here. So this dynamic variable will be replaced with this value, whatever the output we get from first task, right? And that will be passed here, and this will try to execute and give us the complete blog post, right? So let's try to rerun the code. So now let's try to understand this output. So the first one is give me a simple bullet point, right? So it tried to give us the bullet points and try to outline for the topic travel, right? Introduction to the joys of travel, right? Benefits of traveling, tips for planning a trip, right? So it gave us few bullet points, and then this entire value will be passed here as an input to second chain, right? So write a blog post using this outline, whatever outline we got from task 1, that will be passed here, and then here again we are trying to invoke, right, by combining these two tasks. So that will be passed, and then we will get the complete blog post, right? You can pass a topic, it will give you an outline, and then it will also give us a complete blog post, right? So instead of the topic travel, let's try to give AI, right? So we are asking the LLM to give us a bullet point outline and also give a complete blog post on the topic AI, right? So let me kill this and then run the code again. So let me scroll up. Now you can see the first task is, it is giving us a few bullet point outlines for the blog post. The topic is AI, right? Introduction to AI, the history of AI, applications of AI, right? What are the benefits, challenges, future of AI, and conclusion, right? So it tried to give us a few bullet points outline on AI, and then we will pass this as the input to the second one. So we will get a complete blog post, right? So this is our complete blog post, right? So similarly, you can replace this topic with any other topic. So this is sequential chain. Sequential chain means output of first one will be passed as input to the second one. And let's say if you have chain 3, the output of chain 2 will be passed as input to the chain 3, right? So that's how this sequential chain works. So let's quickly review what we have done here. So we have installed all the required packages. In case if you have already installed, you don't have to install it again. Otherwise, make sure you install LangChain OpenAI package, because we are using the modules which are inside LangChain OpenAI, right? And then we try to import the modules. This chat OpenAI module is to initialize our LLM, and this is to create a prompt template, right? And the next thing is we try to load the environment variable, we read the key, and we stored our OpenAI API key inside this environment variable. And then we initialized our LLM by using chat OpenAI, which is inside LangChain OpenAI package. And here we created a simple prompt template, right? Give me a bullet point outline for a blog post on topic. Here topic is a dynamic variable. You can replace this topic with any value, right? And then first thing is we try to create a prompt by using chart prompt template, which is inside LangChain prompts. And we have a method called from template, and we passed this prompt template which we defined here. That is our first prompt. And once we have the prompt and LLM ready, we try to bind our LLM with the prompt by using chain, right? So we got our first chain. And inside chain, we have a method called invoke. So you can call that and pass the topic as our input. So you will get a bullet point outline on the topic that we have provided, right? So that is our first task, and we try to print here. Similarly, we try to define the second template, write a blog post using this outline. Whatever the value we get here, this will be passed to this dynamic variable ABC, and then we created a second prompt by using this chart prompt template. Inside that we have from template and we passed our template, right? So we got the second prompt, and we try to bind our LLM with the second prompt by using the chain. So we created chain 2, right? And we try to combine chain 1 and chain 2 together by using another chain, and we named it full chain. So when we invoke this by passing the topic, then first it will try to execute chain 1, and whatever the output we get from chain 1 will be passed as input to chain 2, and it will try to execute. And we got a complete blog post by using the outline which we got from chain 1, right? So that's how you can implement a sequential chain and execute multiple complex tasks one by one, right? And another example can be, here you can write a prompt, go to a website and download the content. And the second prompt can be, whatever the content you downloaded from first one, just try to summarize it, right? So that is another example. Or another example could be, task 1 can be web crawling, right? So go to a website and try to get the content, and the second task can be summarizing the content, right? So you can use sequential chain in these scenarios, right? So now you get the idea. So whenever you have multiple tasks and one task is dependent on another task, then you can use this sequential chain and try to chain and get the results. So that's how you can use sequential chain. Thank you. So far we have seen how to use single chain, simple sequential chain, and now let's see sequential chain, right? So simple sequential chain, this is the output of the first chain will be passed as input to the second chain, right? Whereas the sequential chain, this will allow for more complex relationships between different tasks. For example, let's say if you have multiple inputs or outputs for each task, then we use sequential chain, right? So now let's go to VS Code and see the implementation of sequential chain. Okay. So we have seen single chain and also simple sequential chain. In single chain, we have given the topic, and then the LLM gave us a funny company name for that topic, right? By using this simple chain. And then in simple sequential chain, we created two tasks and we try to execute one task after another, right? Now let's see the third one, file, new file, Python file, and let's save this as sequential chain demo and save, right? So now let's see sequential chain demo, right? So the first thing is, we have to install all the required packages, and the package is LangChain OpenAI. In case if you haven't installed, make sure you go to the terminal and execute pip install LangChain OpenAI command, right? And the next thing is we have to load all our required modules. This chat OpenAI chat prompt template, and this is for loading the environment variables, right? So we have already seen this code. The first thing is, by using load underscore .env function, we are trying to load the environment variables from this environment file, and we are trying to read the key and trying to store that key inside OpenAI API key. environment variable. And the next thing is, let's try to initialize our LLM by using chat OpenAI, which is inside LangChain OpenAI package, right? So let me close this. So we got our LLM initialized. And now the task number 1. For example, let's say you have an employee review and your employee name is Joe Smith and the position is software engineer, and the employee strengths. Joe is highly skilled software engineer and collaborative nature, that is another strength, right? So these are some of the strengths, right? And the next one is weaknesses, right? So Joe has some weaknesses, right? So here we listed a long text with Joe's strengths and weaknesses, right? So this is our employee review. Now once we have the review ready, now let's try to create a prompt template for task 1. So let's try to define our first template. Give a summary of this employee's performance review, and we are passing this review. This review is stored inside this employee review, right? So we are passing our input as employee review, and we are asking our LLM to provide us a summary of this employee's performance review, right? So we are passing a long text to our LLM and we are asking our LLM to give us a summary, right? So that is the first task. And now let's use this chat prompt template and pass this template, right? So this is our template. This is how we want the LLM to execute, right? So by using the chat prompt template, we have a function called from template and we are passing our template. This is our first prompt. Now we have our LLM ready and we also have our prompt ready, right? Now let's try to bind both these components by using chain. So let's try to create a chain by binding both LLM and prompt. This is the chain representation, right? So we got our first chain. Now let's try to call the invoke method inside this chain 1 and see if the LLM is actually giving us the summary of this employee performance review, right? So let's try to print the results and see. So what we are trying to do here, /n is a new line. I'm just trying to bold this text, summary of employees performance review, so you can see better in the terminal, right? And then we are trying to print 50 times this hyphen, and then here I'm just trying to not bold it, and the result is inside the chain we have a method called invoke and we are passing our employee review, which is the input to our first chain, and we are getting the content, right? So let me save this and run the code. So now you can see the summary of employees performance review, right? So we gave a long text. We gave a long text of employee review and our LLM OpenAI summarized this entire content, right? Overall, Joe Smith is a highly skilled software engineer with a strong technical expertise, collaborative nature, self-motivation, adaptability, and so on, right? So this is the summary. So that is our task number 1. We gave employee review as input to our OpenAI LLM and it gave us the summary, right? This is task number 1. That is to generate a summary of employees performance review by using sequential chain, right? Now let's try to create another template, right? So the second template, this is our second template. Identify key employee weaknesses in this review summary. So this one has the summary, right? By using this summary, try to identify employee weaknesses, right? So that is our task number 2. So again, let's try to create the prompt by using this chat prompt template. We have a function called from template and pass this second template. So we will get the prompt 2. And once we have our prompt ready, and we also initialized our LLM here. So let's try to bind both of them by using chain, right? So we got our chain 2. Now let's try to print this chain 2 and see if our LLM is actually returning us the weaknesses from chain 1's result, which is nothing but the summary, right? So let's try to print the result. Here what we are trying to do, identify key employee weaknesses in the performance review summary. 50 times I'm printing this and then not trying to bold this. So here what we are doing, chain 1 and chain 2, we are trying to bind again by using chain, which is nothing but full chain. We have seen this in simple sequential chain, right? So chain 1 and chain 2, we are binding them together and then calling the invoke method by passing employee review, and we are trying to get the content, right? So this is our task number 2. So the second task is to identify key employee weaknesses from the output of first chain, which is nothing but summary, right? So the output of first chain will be passed as input to the second chain. So let's see the terminal and kill this, and let's try to run again, right? So what we have done so far, we gave this long text of employee review as input to the first chain and then it summarized it, right? And the second task is by passing this summary as input to our second chain, and it gave us the employee weaknesses, right? Time management, written communication skills, delegation abilities, right? So these are some of Joe's weaknesses, right? So this is task 1 to summarize. Task 2 is to identify the weaknesses, right? So we have done 2 tasks here. And now let's create another task, right? So first thing is, let me try to define a template, create a personalized plan to help address and fix these weaknesses, right? So we have identified all the key weaknesses from task 2, right? So we are passing output of second chain to input for the third chain, and then let's try to create the prompt by using chart prompt template. Inside that we have from template function, and we are passing template 3, and once we got the template, let's try to bind both LLM and prompt by using chain, right? So we got chain number 3. Now let's define the sequential chain by using all these 3 chains, right? So sequential chain is equal to chain 1, chain 2 and chain 3. We are just trying to bind all these chains together. Once we bind them, let's try to call the invoke method which is inside chain, right? So results is equal to sequential chain dot invoke, and we are passing employee review as the input. So we will get the summary, and then once we get the summary, here we'll get the weaknesses, and here we will pass the weakness, and then finally we will get personalized plan, right? So we have task 1 give us the summary, task 2 to give us the key weaknesses, and task 3 is to give us the personalized plan to help address these weaknesses, right? So total we have 3 tasks. And now let's try to print the results, right? So create a personalized plan to help address and fix these weaknesses. 50 times we are just printing this, and then results.content, right? So the third task is to create a personalized plan. So now let's kill this and then run again. So if you see here, this is our task number 1. Give us a summary. We provided a long text of employees performance review and it gave us the summary. And task number 2 is it identified the key weaknesses of employee Joe, right? And then finally it created a personalized plan to help address and fix these weaknesses, right? So we got these weaknesses from task 2. Task number 3 is provided a personalized plan to fix these issues for time management, for written communication and delegation of tasks. So this is how it is trying to give us a plan, right? So let's quickly go through what we have done here by using this sequential chain. The first thing is we installed all the required packages, and then we tried to load the modules, and then we tried to load the environment variables from the environment file, and we tried to read the key, and we stored the OpenAI API key inside this OpenAI API key environment variable, and then we initialized our LLM by using chat OpenAI, and then here this is our input, right? So instead of hard coding here, you can try to read it from any other data source, right? So let's say you have a long text of employee review. Here the employee name is Joe Smith, and this is Joe's review, right? And then what we are trying to do here, we are trying to create a template. Give a summary of this employee's performance review. So this is the employee's performance review. So we are trying to ask our LLM to give us a summary, and we are creating our first template, and then we created our chain by binding both prompt and LLM. So first thing is we got our summary, and then similarly we defined our second template, right? So here we defined our template, we created the prompt, and then we tried to bind both LLM and prompt, and we got the key weaknesses, right? So we tried to bind both chain 1 and chain 2 and call the invoke method by passing the employee review. So we got the key weaknesses, right? And then these key weaknesses again we passed as input to third one. So here we are trying to create a personalized plan, right? And then we created the prompt, tried to bind both LLM and prompt, and we created a sequential chain by chaining all these chains together. And then inside the sequential chain we have a method called invoke and pass the employee review as the input. Finally we are getting the personalized plan, right? So that is how you can use a chain to bind LLM with a prompt, or you can also chain multiple chains together. Alright, so that's about sequential chain. Thank you. So far we have seen single chain, simple sequential chain, and sequential chain. In sequential chain we have already seen one of the application. Now let's go to VS Code and see one other application as well by using sequential chain. So let's go to VS Code. So we have seen one of the application by using sequential chain. So what we did here, we passed our employee review and we created the first chain and we got the summary, and whatever the summary we got from the first chain we passed that to second chain and we got the employee weaknesses, right? And then finally we passed that weaknesses to third one and we got the personalized plan to help address and fix these weaknesses, right? So this is how we implemented by using sequential chain. Now let me create one other file and let's save this as sequential chain demo. We already have that, so let me give 2. So the first thing is we have to install LangChain OpenAI package. In case if you haven't installed already, go to the terminal and then type pip install LangChain OpenAI and hit enter. So that way LangChain OpenAI package will be installed on your machine, right? Now the next thing is we need to import all the required modules from LangChain package, right? So here we are trying to import chat OpenAI from LangChain OpenAI and chat prompt template from LangChain prompts, string output parser from LangChain core output parsers, right? So this is used to parse the results, right? And then runnable pass through, this is from LangChain core's runnables, right? And then we are also using item getter from operator. I will explain all this in detail when we are trying to use them, right? So the first thing is like we did before, inside the environment variable we stored our OpenAI API key. Now let's try to load the environment variables from .env file by using load_.env function. And then the next thing is let's try to read the API key, and we are using os module .getEnv function and we are passing the key name, so we will get the value, and whatever the value we get it, we are trying to store that inside OpenAI API key environment variable, right? So far we installed all the required packages, we loaded the modules, and then we read the API key from our environment file, right? Now in order to chat with our LLM, we need to initialize our OpenAI LLM by using chat OpenAI, which is from LangChain OpenAI package, right? Once we have the LLM ready, the next thing is let's try to define a prompt. So here we are using chat prompt template, which is from LangChain prompts. Inside that we have a method called from messages, and here this is our prompt. What we are doing here, system, you are a helpful assistant who generates interesting topics. User, generate a random academic topic for discussion. Okay, so this is our prompt. And then let's try to create a chain, because now we have our LLM and the prompt ready. Let's try to bind this LLM with the topic prompt by creating a chain. So here we are trying to create a chain by binding this LLM with the prompt and also string output parser. This is to parse the result, right? So that is our first chain. Now let's try to create another chain to generate questions about this topic, right? Because we are asking to generate random topic for discussion, right? So let's try to define another prompt, the second chain, to generate questions about whatever topic we are getting here, right? So the question prompt is equal to, but again we are using chart prompt template, which is from LangChain prompts, and inside that we have a method called from messages. And system, you are a helpful assistant who generates thought-provoking topics, and user, generate 3 thought-provoking questions about this topic. So here we will get a random academic topic, and this topic will be passed to the second one. So we will get 3 thought-provoking questions about whatever the topic it selects, right? So that is our second prompt. Now we have our prompt ready. We also have our LLM ready. Let's try to bind this question prompt with LLM by using chain. So let's create question chain. We are trying to bind this LLM with the prompt that we just created, and also string output parser. So we have topic chain and also question chain ready. Here we will get a random academic topic, and then here we are passing the topic, so we will get 3 thought-provoking questions about whatever topic we selected from chain 1, right? Now let's try to create a sequential chain by using this topic chain and question chain, right? So here we are trying to create a sequential chain. What we are doing here, for topic we are assigning this topic chain and runnable pass through, and then topic item getter topic. So when I run, then you will see. And for questions we are passing question chain, right? So this is how we created our sequential chain. So once we created the chain, we know inside the chain we have a method called invoke, right? So let's call that method so we can see the results. So results is equal to sequential chain dot invoke. So that will give us the results. Now let's try to print these results, right? So you can see, generate 3 thought-provoking questions about a random academic topic, and this text we are trying to bold with this, and then 50 times we are trying to print this, and then here I'm trying to not bold this result, and then we are trying to get the 3 questions, right? So that is what we are trying to print. Now let me save this code and let's try to run this code and see. Okay, so now you can see we are trying to print, generate 3 thought-provoking questions about a random academic topic, right? And those 3 questions are this one, and the topic that it selected is artificial intelligence, right? So if you see the output here, how can the integration of artificial intelligence in cybersecurity lead to more effective and proactive threat detection and response mechanisms? What ethical considerations should be taken into account when utilizing AI in cybersecurity? In what ways the use of AI in cybersecurity be balanced? So looks like the topic is artificial intelligence in cybersecurity. So that is the topic it selected, and then it is trying to generate 3 questions for us, right? So that is what we are asking our OpenAI LLM to generate. And this runnable pass through, this is a function inside LangChain. This will just pass the output as it is to the next layer, right? So whatever question we are passing, that will be passed to the next layer as it is. So that is why we are using this runnable pass through. And then topic, for topic we are passing the topic chain, that is the first chain. And this is topic number 1, 2, 3, right? So to generate the numbers, so topic 1, 2, 3, and then questions, these are the 3 questions. So here we are asking to generate 3 thought-provoking questions about whatever the topic it selected from the first chain. And if you want to see just the topic alone, you can call topic chain. Inside that we have the method called invoke, right? So you can invoke that and then see what it is returning, right? So let's try to kill this and then let's try to rerun the code and see. So if you see the questions here, it selected virtual reality technology, right? So how can virtual reality technology be effectively integrated into traditional mental health treatment methods to enhance therapeutic outcomes? So this is the second question and this is the third question, right? So again it generated 3 questions on using virtual reality technology, right? So If you want, you can just kill this and let's try to rerun the code again. So every time it is trying to generate a random topic and also generating 3 thought-provoking questions, right? So how can society ensure that the benefits of increased efficiency and productivity from AI are equitably distributed among all members of the workforce? And the second question is, what measures can be taken to retain and upskill workers whose jobs are at risk of being automated by AI? How might the rise of AI and workforce automation challenge traditional notions of work, job stability, and so on, right? So it created again 3 topics. And if you are interested, you can rerun the code again and see what topic it is trying to select and what kind of questions it is trying to generate, right? So again, it generated 3 questions related to AI. So let me close this. So let's quickly review what we have developed here. So the first thing is we installed LangChain OpenAI package. We imported all the required modules and then we tried to load the environment variables from this environment file and then the API key, and then we stored the API key inside OpenAI API key, and then we initialized our LLM by using chat OpenAI, and then here we created our first prompt. So we are telling our LLM to generate a random academic topic for discussion, right? So this is our prompt. And then we are trying to bind this LLM with the prompt and also string output parser by using chain, right? And we assign that to topic chain. And similarly, we created second chain to generate questions about whatever the topic it is selecting, right? So the prompt is generate 3 thought-provoking questions about this topic, whatever the topic it is selecting, right? And now again we created another chain by binding the LLM with the prompt by using chain, and we assigned that to question chain, right? And then once we have both topic chain and question chain ready, we are creating a sequential chain. We are assigning topic to topic chain and runnable pass through, and then this is just the topic numbers, right? And then the questions, and we are assigning this question chain, and this is the sequential chain, and we are calling the invoke method, so we'll get the results and we are trying to print the results, right? So this is how you can use this sequential chain to perform a complex task by binding multiple chains together, right? So if you notice here, again we are using chain to combine multiple tasks and perform a complex task. All right, thank you. So far we have seen single chain, simple sequential chain, sequential chain, and the next one is MathChain, right? So if you are building a generative AI application that involves a lot of math calculations, then we can use this MathChain. So now let's go to our VS Code and see how we can implement this MathChain, right? So this is our VS Code. So we have seen single chain, simple sequential chain, sequential chain, right? Now let's create a new Python file and let's save this as MathChain demo. And now let's try to ask a simple math question and see how the LLM responds. The first thing is we need to install all the required packages, right? I'm trying to install LangChain OpenAI package. So this is one other package. So make sure you install these packages if you haven't installed already, right? And then the next thing is we need to load all the required modules, right? So here we are trying to load chat OpenAI from LangChain OpenAI, LLM MathChain from LangChain Chains, and human message from LangChain schema, and load.env from .env, right? And this is the OS module. Now the first thing is let's try to read the environment variable from this environment file, right, by using load_.env function. So that is our step number 1. So we are trying to load the environment variables from this .env file. In case if your environment file is stored in some other directory, then you have to navigate to that directory and then try to read the key, okay? And then we are trying to store the API key inside this environment variable, OpenAI API key. And once we have the key, the next thing is let's use this chat OpenAI from LangChain OpenAI and then try to initialize the LLM. So this is our LLM. Now let's try to ask few math questions to our LLM OpenAI and see how it responds. So this is our LLM. Inside the LLM we have a function called invoke, and then we are passing this human message which is from LangChain schema, and we are passing this question: what is 17 raised to the power of 11, right? So this is our math question. And now let's try to see what we have inside this result, right? So let's try to print the results. So here we are just trying to bold this text. What is 17 raised to the power of 11? We are just trying to bold that text, and then 50 times we are printing this hyphen, and then we are trying to get the value of the content from this result, right? So now let me save this code and let's run the code and see. So you can see what is 17 raised to the power of 11. It is giving 17 to the power of 11 is equal to this value, right? So what we did here, we haven't used LLM MathChain yet. Here we are directly passing the question and trying to get the answer. We installed all the required packages, we imported the modules, and then we read the key. We stored inside OpenAI API key, and then we initialized our LLM, and then we passed this question and we try to call the method invoke, and we are trying to print the results, right? And then let's try to ask one other question. So what we are trying to ask here, the question is, give me the Python formula that represents what is 17 raised to the power of 11. Only reply with the formula, nothing else. Okay, so we do not want the result. We want the formula to represent in this format, right? Now let's try to print the results and see what we have inside this content, right? So let's kill this terminal and then let's rerun the code. So now you can see it only gave the formula, right? Because the question that we are asking the LLM is, give me the formula that represents this. Give me the Python formula that represents what is 17 raised to the power of 11. Only reply with the formula, nothing else, right? So that is what we asked the LLM, and the LLM gave the formula, right? So you can see the difference here. So here we are directly asking what is 17 raised to the power of 11. So we want the value here. So that's why we got the value. And then here we are asking just the formula, right? So that is why we got the formula here. Now let's try to use this LLM MathChain and see how we can solve a math question, right? So by using this LLM MathChain, which is inside LangChain Chains, let's try to use LLM MathChain. Inside LLM MathChain we have from LLM, and we have to pass this LLM. So we will get LLM math model, right? So once we have the LLM MathChain model is ready, now let's try to ask another question, right? So here I'm just trying to print what is 17 raised to the power of 11, and then let's print 50 times this hyphen, and then this is, I'm just trying to make this text bold, and this one I'm just trying to not make the text bold. And then let's try to ask a question. So inside the chain we have a function called invoke, and then we are passing the math question. What is 17 raised to the power of 11, right? So this is by using LLM MathChain, right? Let's try to, so let me just kill this, and then now let's try to rerun the code. So you can see by using LLM MathChain, question what is 17 raised to the power of 11, answer this is the value, right? You can try any way, right? Okay, so this is how you can implement any math question, right? So what we did here, we installed all the required packages, and then we tried to load the modules, and then we read the API key, we initialized the LLM, and then here we are trying to call the invoke method, and we are trying to pass the math question and trying to get the results, right? And the second question is, we are asking the LLM to just give only the formula, nothing else, right? So that is why it gave us the formula alone. And then finally we are using LLM MathChain, which is from LangChain Chains, and then here we are passing the LLM to from underscore LLM function, and then we are calling the invoke method and passing the question, so we are getting the answer, right? So that is how you can use LLM MathChain. So whenever you are trying to implement any generative AI application that involves math, right, then in that case you can use LLM MathChain and try to make use of this, right? Thank you. So in the previous lecture we have seen how to use LLM MathChain, right? Now let's see one other application by using this MathChain. So let's go to VS Code and see one other application. So this is our chains demo. Inside that we are trying to create a new Python file. And let me try to save this as MathChain demo 2, right? And you already know, first thing is we have to install all the required packages. Here we are using LangChain OpenAI and this one too. Now let me try to load all the required modules. So we are using OpenAI LLM. So we are trying to import chat OpenAI from LangChain OpenAI, and then chat prompt template from LangChain prompts, and LLM MathChain from LangChain Chains, and load.env from .env and OS module, right? We have already seen this numerous times. The first thing is we have to load our environment variables from the environment file by using load_.env function, and then we are trying to get the API key by using os.getEnv function, and then we are trying to store that inside OpenAI API key. Okay, now the next thing is let's try to initialize this OpenAI by using chat OpenAI and assign it to a variable called LLM. That is how we initialized our LLM. Now by using this chat prompt template, let's try to create a custom prompt template for the MathChain, right? So what is our math prompt? Here we are trying to define our math prompt, right? So we are using chat prompt template, which is inside LangChain prompts, and we know inside that we have a method called from messages, and here we are trying to pass the prompt. So our prompt is system, you are a mathematical assistant that helps solve math problems. Given a math problem, respond only a Python expression that can be evaluated to solve it. You must start your response with answer followed by the expression. Do not include any other text or explanations, right? And here we are trying to provide the examples. For example, question, what is 2 plus 2? You provide the answer as 2 plus 2. And if the user asks, if I have 3 apples and multiply them by 4, how many do I have? And you want the LLM to respond as 3 times 4 as an expression. And then if user asks what is 25 times 4, you want the LLM to respond as 25 times 4 as an expression, right? So this is the prompt that we defined, right? So if you notice here, we are guiding the LLM with few examples, right? This prompt is nothing but few shot, which we have seen already. If you go to prompt engineering demo and go to few shot, so here you can see we are guiding the LLM in this way. So if the customer says this, you want the LLM to respond this way. If the customer says this, you want the LLM to respond this way. So we are guiding the LLM by providing some examples, and we are trying to provide the context so it can respond accordingly, right? Which is nothing but few shot. So here we used few shot prompt engineering technique, and then we created a math prompt, right? So this is always better to give some examples when we are trying to solve math based questions, right? So we are trying to provide the LLM more context by guiding it with some examples. Now let's try to create a math chain by using this LLM math chain, right? So we are using LLM math chain. Inside that we have from LLM, and for LLM attribute we are passing our LLM which we initialized before, and then for prompt attribute we are passing our math prompt which we just defined, right? So we try to bind the LLM with the prompt by using this LLM math chain. So we got the math chain ready. Now we know inside math chain we have a function called invoke, right? So now let's try to ask a question. What is the question? What is 25 times 4, right? And let's try to see if the LLM is responding, right? Math result is equal to, inside the LLM chain we have a function called invoke, and then for question we are passing this question, right? Now let's try to print both the question and also the answer, right? So let me try to save this code and run the code. So you can see what we asked, what is 25 times 4? And the answer is 25 times 4. So you want the LLM to respond this way, right? Now let's change this to 100 and see if the LLM is responding correctly. So now you can see the answer is, you want the LLM to respond in this way. answer colon 100 times 4, right? So here we are using only simple math question, but you can also replace this question with some complex math questions, right? With the complex math questions, the LLM may not be able to answer without this math chain, right? So this LLM math chain is more beneficial when you are trying to solve more complex math problems, right? With simple questions, you may not be able to see the difference with or without math chain, but you will see the difference when you are trying to solve some complex math questions, right? So that is the benefit of using this LLM math chain, right? Because what we are telling, the objective of this prompt is to respond only in this way, right? If this is the question, you respond this way. If this is the question, you respond this way. If the user asks in this way, then you respond this way, right? But if you want the answer in a different format, then you can change the prompt here, right? So the LLM will answer based on how we provided our prompt, right? So let's quickly review. We tried to install all the required packages and we loaded all the required modules, and then we tried to load the environment variables from this environment file, and we read the key we stored inside OpenAI API key. And then next thing is we initialized our LLM, and then here we created a prompt. This is nothing but few short because we are giving the examples, right? So this is how we defined our prompt by using chat prompt template from messages. And we used LLM math chain, and inside LLM math chain we have a function called from LLM, and for LLM attribute we passed this LLM, and for prompt we passed the prompt that we created. And then this is the question we are trying to ask the LLM. What is 100 times 4? And inside the chain we have a function called invoke, and we are passing the question, and we are trying to print both question and answer, right? So this is how we are getting the answer, because here we give answer, so that is why this answer, and then the result is this one, answer in this format, answer colon whatever the expression, right? So depending on the prompt, the LLM will try to understand the context, and then it will try to solve the math question. Here we are using LLM math chain. Instead of this simple math question, you can try to solve some complex math problems as well, right? So that is the objective of using LLM math chain. All right, thank you. So far we have seen single chain, simple sequential chain, sequential chain, math chain, right? Now let's see RAG chain. Let's go to our VS Code and try to implement RAG chain, right? So this is our VS Code. So let me create a new Python file, and let's save this as RAG chain demo. And like you know, the first thing is we have to install all the required packages. So here we are using LangChain OpenAI package. So make sure you install this package, and then the next step is try to load all the required modules from this LangChain OpenAI, right? So here we are trying to get all the modules that are required to implement RAG chain, right? So once we install all the required packages, and then once we load the modules, the next step is here we are using OpenAI as our LLM. So we stored our OpenAI API key inside this environment variable. So let's try to load the environment variables from this environment file by using load_.env function, and then here we are trying to read the key, and we are trying to store the API key inside OpenAI API key environment variable, right? And now let's use this chat OpenAI and try to initialize our LLM. Okay, and then we already know RAG flow because we have already seen the RAG demo. So what we do with RAG, we try to create our domain specific input document, and then here we are hard coding, but you can use document loaders and then try to load the input document and then chunk the document, and these chunks are in text format and the LLM cannot understand text. So the next step is we are creating the embeddings, right? And then once we have the embeddings, we are trying to store them inside a vector database, right? So which is nothing but RAG flow. Now let's see how we can implement the same here, right? So first thing is let's try to define our input document. So this is our input document. We have HP printer sales are up by 30% in 2011 Q4. Lenovo laptop sales are down by 10% in 2012. A3 printer sales is 5% more in Middle East as compared to A4 total, right? So this is our sample document. Here you can replace this and load this document from any other data source by using our document loaders, right? Which we have seen already. But for our demo, I'm just hard coding the values here, right? So this is our input document. Now the next thing is we have to split this input document. So this entire text will be divided into multiple chunks, right? So let's try to create text splitter and split the input document, right? Here we have imported recursive character text splitter, which is inside LangChain text splitter, right? So let's use this recursive character text splitter and split our input document. So we are using recursive character text splitter and we are saying the chunk size as 100 characters and chunk overlap is 20. So that means this 20 characters will be overlapped with the following chunk, right? So once we have this text splitter, we know inside this we have a method called create documents, which will give us the splits, right? So inside the recursive character text splitter, we have a method called create documents and we are passing our input document. So we will get the splits, right? So now if you want to see what we have inside the splits, let's try to print it, okay? So document has been split into, we are using the function length and passing this splits. How many splits, right? So this document has been split into these many chunks, right? And then let's try to print them. Example chunks. I'm just trying to bold this text and then just trying to print 50 times the hyphen, and then now let's print the values, right? So this is a list. So I'm just trying to loop in and trying to print each chunk value, right? So chunk 1, what is the value? Chunk 2, what is the value? Chunk 3, what is the value, right? So here we have 3 values. So it will create 3 chunks, right? So depending on your input, it will try to create the chunks. And to create the chunks, we are using recursive character text splitter, right? And once we have these chunks are in text format. But OpenAI LLM cannot understand text. So we know we have to convert this text into numbers, which is nothing but embeddings, right? So let's define our embedding model. Here we are using OpenAI embeddings, right? Which is from LangChain OpenAI. So let's use that and then define our embeddings. We are using OpenAI embeddings, right? So once we have our embeddings ready, the next thing is let's create a vector store so we can store these embeddings. So let's try to create a vector store using the initialized embeddings model, right? So make sure you install this ChromaDB in case if you haven't installed already, right? So let me add that as well. Pip install ChromaDB. Make sure you install this in case if you haven't installed already. So you can use this ChromaDB. Inside that we have a method called from documents, and for documents attribute we are passing our splits, that is our chunks, and for embedding we are passing our OpenAI embeddings model, right? So we created our Chroma database where we can store our embeddings, right? Now next thing is let's try to create the retriever. So inside this vector store we have a function called as retriever. So that will create a retriever, right? So we created our retriever. So we already know the rack flow, right? We are converting these chunks into embeddings and we are trying to store those embeddings inside our vector database, which is nothing but a Chroma database, right? This Chroma database will store these embeddings inside your local memory, right? Instead of Chroma database, you can use any other vector database also. We have seen different types of vector databases already, right? Now we have imported chat prompt template, which is from LangChain prompts. So let's use this and try to create a prompt so we can chat with our LLM and see if our LLM is trying to retrieve the results from this input document, right? So let's try to create a template, create a RAG template, and this is our template. Answer the following question based on the provided context. The context is we are storing inside this question is this, and we want the LLM to respond in this way. So this is just a template, right? Now let's create a prompt by using chat prompt template. Inside that we have a method called from template, and let's pass this template, right? So we got our prompt ready. And now the next thing is let's create the chain, because we have our prompt and we also have our LLM ready. Let's try to bind both these by using the chain. So let's create a RAG chain. So this is our RAG chain. What we are doing here for context, we are passing retriever where we stored all our embeddings, question, runnable pass-through, right? So this runnable pass-through is a function inside LangChain. It will pass the output as it is to the next layer, right? So whatever question we are passing, that will be passed to the next layer as it is. In case if you want to learn more about this, you can go to LangChain documentation and learn more about it, right? And then we are trying to bind prompt, LLM and string output parser by using the chain, right? So always remember this pipeline represents a chain, right? Now we have our chain ready. So we try to bind our prompt, LLM and the output parser and the embeddings, everything we try to bind all of them by using this chain, and we created our RAG chain, right? Now once we have the chain ready, inside the chain we have a method called invoke. So let's try to call the invoke method on this chain and then see if our LLM is trying to give us the answers, right? So this is our text, right? So this is about HP printer, Lenovo laptop and A3 printer, right? So let's try to ask one question regarding this HP printer. What is HP printer sales in 2011 quarter 4, right? So what we have given, HP printer sales are up by 30% in 2011 quarter 4. So that is our question. And how do we get the answer? We have to call the invoke method which is inside this chain and pass our question, so we will get the answer, right? Now let's try to print the results. So this is the question. I'm just trying to bold this by using this, and then let's also print answer. Here I'm not trying to bold this answer, only the question I'm trying to bold with this one, right? And the answer is stored inside this answer variable, right? So we are trying to print both question and answer. That is, you have to remember the question that we asked is specific to our input document, right? So here you can replace with any of your domain specific, that is your organization domain specific input document. So this is nothing but a RAG application, right? So let's try to save this code, run and see if our LLM is able to answer to this question. So let's run the code and see. So this is the answer it has given. So now let's verify if it is correct. So you can see HP printer sales are up by 30% in 2011 quarter 4, right? So that is the question we asked, and the LLM was able to predict the right answer, right? And it also printed this one. So we are trying to print the chunks also, right? So it divided into 3 chunks. This is the first chunk and this is the second chunk. This is the third chunk, right? So this is nothing but RAG chain, right? Let's try to ask another question which is not inside this document and see what our LLM is going to do, right? So instead of this question, so what we have inside this, we have HP, Lenovo and A3 printer, right? So instead of HP, let's try to give Apple and see how the LLM is going to respond. So I'm going to kill this session and then rerun the code and see. So the question that we asked is, what is Apple printer sales in 2011 quarter 4? The given context doesn't contain any information about Apple printer sales, so it is not possible to determine Apple printer sales in 2011 quarter 4 based on the provided information, right? Because if you see our input document, we did not specify any information related to Apple printer, right? So the LLM was not able to give us the answer, right? So you can experiment, right? You can try to change this input document and try to use the RAG chain and then see if the LLM is trying to retrieve the results, right? So you can replace this input document. Let's say if your document is in a PDF file or a text file or any other document or any other data source. So you can try to load them by using document loaders, and you can do the same, right? So this is how you can build RAG chain. So what we have done here, let's quickly review. Let me close this. We try to install all the required packages, and then we try to load the modules that are required, and then we load the environment variables from this environment file where we stored our API key, and then we read the key we stored inside our OpenAI API key environment variable, and then we initialized our LLM. So once we have the LLM ready, the next thing is here we are trying to store our input document inside this documents variable. This is nothing but a list. Instead of this hard-coded values, you can replace with any of your domain specific data. You can load them by using document loaders, right? And once we have your input document ready, we are using recursive character text splitter to split our input document. We are using chunk size as 100, so we are telling it to divide by 100 characters and also try to overlap 20 characters from each chunk so that we can preserve the context. So you have to choose these user defined parameters depending on your input document, right? And then we have our text splitter. Inside that we have a method called create document. So we passed our input document. So we got our splits, and these splits are in text formats. Here we are just trying to print them. So we have to convert these text chunks into embeddings by using OpenAI embeddings, which is inside LangChain OpenAI. Next thing is, once we have these embeddings ready, we have to store them inside a vector database. Here we are using Chroma database. Inside that we have from documents method, we are passing our splits to documents and embeddings to embedding attribute, right? So we got our vector store. And now let's retrieve them by using as_retriever function. So we are storing them inside a retriever variable. Now let's create a RAG template. So this is our template and this is our prompt. We are using chat prompt template. Inside that we have a function called from template, and we are passing our template, right? So once we have our embeddings, LLM and prompt, all of them are ready. Let's try to bind them by using this chain. So here we are trying to create a RAG chain, and we are passing the context as retriever where we have our embeddings and question runnable pass through, and this is our prompt, LLM and string output parser to parse the results, right? Now here we are just trying to print the question and answer. This is the question we asked, and we are trying to call the invoke function which is inside the chain. So we are passing the question, so we are getting the value of the answer, and we are just trying to print them here, right? So this is how you can create a RAG chain. Instead of this input document, you can replace this with any other input document and try to experiment this, right? So this is how you can create a RAG chain. All right, thank you. So far we have seen single chain, simple sequential chain, sequential chain, MathChain, RAG chain, right? Now let's see router chain. Okay, so what we did in sequential chain, we can only run sequential tasks, that is tasks that are dependent on each other, one task after another, right? So for example, let's say your task is to create a research report, right? So one task is it finds the data with a markdown file first, and then the output of the first task will be passed again to the second, and the second task is to summarize, and the third task is to create the report, right? That is, first thing is to identify the file, second one is to summarize the data, third one is to prepare the report, right? And all these tasks are dependent on each other. That is, we will do one task after another. This is nothing but a sequential chain. Here every task is executed one after another. Whereas if you use router chain, this will help you to route the question to the correct one, so the LLM can respond accordingly, right? So for example, let's say you are building a generative AI application and we don't know what kind of question the user asks, right? So the user can ask either a science question or a history question or a math question, right? So in this case, we will define prompts for all the different types of questions, right? If the user asks only a math question, then you can just simply use MathChain, right? Which we have seen already. But we need to build a generic application so user can ask any kind of question. It can be math or science or history, right? Not just math related question, right? So the objective of router chain is based on the prompt or based on the question, the LLM will be able to route the question to the correct prompt and answer accordingly, right? So now let's go to VS Code and see the implementation of this router chain, right? So far we have seen these different kinds of chains. Now let me create a new Python file and let's name this as router chain demo. Inside the chains demo, I'm creating a new Python file and naming it as router chain demo. And the first thing is, like we have done before, make sure you install LangChain OpenAI package, right? So once you install all the required packages, in this case it is LangChain OpenAI package, right? If you haven't installed already, make sure to go to the terminal and install it. And then next step is try to load all the required modules from LangChain package. And then the first step is, let's try to load the environment variables from .env file. Inside this .env file, we stored our OpenAI API key. That is the LLM we are using to demonstrate router chain. Okay. So the first thing is, let's try to use load_.env function to load the environment variables from this environment file. And the next step is read the API key. By using this OS module, we have a getEnv function and pass the API key name. So we will get the value of OpenAI API key. Once we get the value, let's try to store this API key inside OpenAI API key environment variable, right? So far we have installed all the required packages, we loaded the modules and we read the key and we stored inside our OpenAI API key environment variable. Okay. Now by using this chat OpenAI, let's try to initialize our OpenAI LLM. So we are assigning that to LLM variable. Now the next step is, let me close this. Let's try to define prompts for different types of user questions. So user can ask a science question or a history question or a math question, right? So user can ask any kind of question. So let's try to define different prompts for different types of user questions. Okay. For example, let's say if user asks a science question, you are a scientific expert, answer the following question, and we are passing the dynamic variable, this is input, and we will pass this value when we are invoking. So similar to science prompt, let's define a history prompt as well. So inside the prompt template, which is from LangChain prompts, we have a method called FromTemplate and we are passing the prompt here. You are a historical expert, answer the following question. So based on the input, you have to answer the question. Again, this input is a dynamic variable. So similar to how we have defined science prompt, history prompt, let's try to define one other prompt. And this is math prompt, FromTemplate.FromTemplate, and we are passing the prompt here. You are a mathematics expert, answer the following question, and we are passing the dynamic variable input. Okay, so far we have initialized our LLM and we defined 3 prompts: science prompt, history prompt, math prompt by using prompt template, and inside that we have from template function. To that we passed our prompt. Okay, now for each of these prompts, let's try to create 3 separate chains by binding the LLM with each prompt, right? Science prompt, history prompt, and math prompt. Okay, so now let's try to create the destination chains. So for the science chain, what we are doing, science prompt, LLM, and the string output parser, right? So we are trying to bind all these 3 by using chain, and we created a science chain, right? So here we are trying to bind the LLM, which is the brain, and then the prompt, which is nothing but the question, and the string output parser. All together we are trying to bind and create a science chain, right? So similarly, let's try to bind history prompt with the LLM and the output and create history chain. Okay, so history prompt, LLM, and string output parser. And similarly for the last one, math prompt, let's try to create math chain by binding LLM, math prompt, and the output. So we created 3 chains here, one for science, the other one for history, and the last one for math. Now let's try to create the router prompt where it can route accordingly, right? So we are trying to create a router prompt by using prompt template, which is again from LangChain prompts. We have from underscore template function, and this is the prompt we are giving. Given a question, determine which category it belongs to, science, history or math. Only respond with the category name. So we are trying to guide the LLM. This router prompt will return the category, whether it is science or math or history, right? So the output of this router prompt is the category name, right? Now, once we have the router prompt ready, now let's try to create a router chain by binding our LLM with this prompt. So that will be the fourth chain. So far we have created these three categories chains. Now let's create the router chain by binding this router prompt with the LLM and the output. So we got our router chain. Now we have to route them based on the category and execute accordingly, right? So now let's try to define a small function. So we are trying to define the routing logic by creating a function by using the def keyword, and we are creating the function name as route chain, and we are passing this input text, and category is equal to router chain dot invoke, and we are passing the input text. So here this will give us the category name in lowercase, okay, by calling the router chain dot invoke, and we are passing the value, so we will get the category name. And if the category name is science, then return science chain, okay. Elif, if the category name is history, then return history chain, okay. Otherwise the last one, return math chain, right? Unexpected indentation, okay. So we defined a routing logic here. So this will give us the category name in lowercase. If the category is in science, then return science chain. Otherwise, if it is history, return history chain. Otherwise, return math chain, right? So here we are defining the routing logic manually, right? So this will return either science or history or math, and according to the category, we are trying to route to the corresponding chain. So that's all this function does. Now let's define the questions, right? So let's define three different questions, one for science, one for history, and one for math, okay. So one is science question, history question, and math question. So we defined three questions, and now let's try to print the answer by invoking each chain, right? So this questions is a list. We have three questions inside this. For each question, we are trying to print the question, and we are calling this function and passing that question, right? So what will happen? Route chain of what is the question? The question is what causes photosynthesis. So that will be replaced here. And then if we pass what causes photosynthesis here, then it will try to invoke and pass the input as what causes photosynthesis, right? And then this logic will return science. And then again chain dot invoke. Which chain will be called here? Since it is a science question, it will call science chain, right? So that will be our answer. So now let's try to save this, and now let's try to execute this code and see. So you can see what causes photosynthesis, and the answer is this. Who was the first president of the United States? And the answer is this, George Washington. And what is the square root of 100? The answer is 10, right? So we asked one science question, one history question, and one math question, and we defined the logic here, and based on the question that we pass, it is trying to give us the category name, and based on the category, we are trying to route accordingly and call the corresponding chain, right? So what we did here, first we installed all the required packages, and then we loaded the modules, and we read the key, and we stored inside our OpenAI API key. And here we initialized our LLM by using chat OpenAI, and here we defined three prompts, science prompt, history prompt, and math prompt by using prompt template dot from template, and we passed our question, right? You are a scientific expert, answer the following question. You are a historical expert, answer the following question. And you are a mathematics expert, answer the following question, and we passed our input, right? This input is nothing but the question that we will be passing, right? So this input will be replaced with the question. And then again we created our destination chains. For each prompt we try to bind that with the LLM, and then here we created the router prompt. So given a question, determine which category it belongs to, whether it is science or history or math. Only respond with the category name, right? So your task is to give me only the category name. Accordingly, I will route. And we have 3 different chains. Those 3 chains will execute and it will give us the answer, right? Once we have the router prompt, we are trying to bind the LLM with the prompt and the string output parser, which will give us the router chain. Here we are trying to invoke by passing this question. So we have 3 questions, right? So that will be passed here. So what is our prompt? Given a question, determine which category, right? So we are passing the question and it will give us the category, right? So 3 questions, 3 categories. Accordingly, it will return the corresponding chain. And where are we calling this router chain here? For each question. So we have 3 questions. For each question, we are trying to print the question, and also the chain is equal to router chain of question, right? So we will be passing the question for each question. This will give us the category. And once we have the chain ready, we are trying to invoke it by passing the question as the input. So we will get the answer, right? So for science question, it executed the science prompt and it gave us the answer. For historical question, it executed this prompt and it gave us the answer. Similarly for math, right? And we are trying to print what is the question and what is the answer for each question, right? If you notice here, we are defining this routing logic manually, right? So depending on the category, route to the corresponding chain and execute the corresponding prompt and then respond, right? But you don't have to define this routing logic manually. The objective of router chain is based on the prompt or question, the LLM is smart enough to route the question to the corresponding prompt, right? So here we defined based on the category we are trying to route, right? So we are defining the logic here manually, but the objective of router chain is to route accordingly depending on the question or prompt that we pass, right? So we have another chain called LLM router chain, right? So let's see another example where it can dynamically route to the correct prompt or question. So we have a direct function available that can do this routing logic dynamically. So the objective of router chain is based on the prompt or question. The LLM will be smart enough to route the question to the correct prompt. We do not have to define this logic manually and route them accordingly, right? So instead of defining this logic manually, let's use LLM router chain and see how our LLM will be able to answer the question according to the prompt that we provide, right? Thank you. So far we have seen all these chains, right? So in the router chain, we have defined the logic manually and then routed accordingly, right? But now let's try to use LLM router chain, and the objective is based on the prompt or question that we provide, the LLM will be smart enough to route the question to the correct prompt and answer accordingly, right? So let's see how we can implement that by using LLM router chain. Okay, so let's go to VS Code and see the implementation part. So if you notice here, with router chain, we have defined this routing logic manually, but now let's see LLM router chain. So let me try to create a new Python file and let's save this as LLM router chain demo. And the first thing is we have to install the required packages, and the package is nothing but LangChain OpenAI. So make sure you install it if you haven't installed already. Okay. And the next thing is we have to load all the required modules. So here we are using OpenAI LLM. So that's why we are importing chat OpenAI from LangChain OpenAI. And the prompt that we'll be using is multi-prompt chain, which is from LangChain Chains router. And this is to load the environment variables from the environment file, right? So we can use load_.env to load the environment variables from the environment file. And once we load the file, let's read the key. And once we have the key, let's store that key inside OpenAI API key. Inside this environment variable, we stored our OpenAI LLM API key. So once we read the API key, the next thing is let's try to initialize the LLM by using this chat OpenAI, which is from LangChain OpenAI package, right? So once we initialized our LLM, for example, let's say you have different templates. One is beginner template, the other one is expert template, right? So let's define our templates. The first template is beginner template. You are a physics teacher who is really focused on beginners and explaining complex topics in simple to understand terms. You assume no prior knowledge. Here is the question and we will pass the question. Okay. So this is our beginner template. This is how we defined our template. Now let's define one other template. Let me close this so you can see better. Expert template. You are a world expert physics professor who explains physics topics to advanced audience members. You can assume anyone you answer has a PhD level understanding of physics. Here is the question and we will pass the question. This is a dynamic variable, right? So one is for beginners and the other one is for advanced audience members and they are PhD level members, right? So we have defined one beginner template and the other one is expert template. Okay. And if you want, you can add your own templates as well, right? So let me define an empty template. Here you can fill in with your own template. So here I have created one for beginner and the other one for expert. Instead of these two, you can add your own templates as well. Okay. So once we have the templates ready, now let's define the prompts, right? So let's create a list of prompts. So what we are doing here, inside the list, we are defining 3 prompts. One is for empty prompt. Name is equal to empty and description is equal to replies to empty questions. For the prompt template attribute, we are passing the empty template. And the second one is for expert template, right? Name is equal to advanced physics. Description answers advanced physics questions. And the prompt template is expert template. Similarly for the beginner template. Name, beginner physics. Description, answers basic beginner physics questions. Prompt template, whatever the prompt template we have created before for beginner template, we are assigning that to prompt template, right? So we have created a list of prompts. One is for empty template, the other one is for expert template, and the last one is for beginner template. Okay. Once we have all these prompts ready, we also have our LLM ready. Now let's try to bind them by using chain. Okay. So here we are using multi-prompt chain, which is from LangChain Chains router, right? To bind the LLM with the prompts. So let's try to create our routing chain call. By using multi-prompt chain, we have a function called from prompts. So we are passing our LLM, which we have initialized here, and also all the prompts. This is the list that we have created. We are passing that and verbose is equal to true, right? Now once we have the chain, inside chain we have a function called invoke, and to that let's try to pass the question. How do magnets work? Explain, right? So inside the chain we have function called invoke and we are passing the question and are trying to print the answer, right? So one beginner question and one advanced level question, right? So we asked 2 questions here and we did not define any logic where it has to route to the corresponding chain, right? Because in the router chain, if you see, we have defined the logic manually. So according to the category, you execute and give us the answer, right? Here we have defined the logic manually. But whereas with the LLM router chain, we are using multi-prompt chain and we are passing all the prompts. So the OpenAI LLM will be smart enough to understand this question and route to the corresponding prompt and give us the answer, right? So based on the question, it will route to the correct prompt and give us the answer. Okay, so that is the objective of using LLM router chain. So now let's try to run this code. So now you can see it understood how do magnets work explain as beginner physics question, and how do Feynman diagrams work, it understood as a advanced physics question, right? So for this question it used beginner template prompt, right? And then it tried to give us the answer. So this is the question input and the answer is this. And the second question, the input is how do Feynman diagrams work, and it understood as advanced physics question. So this is the input and this is the answer, right? So what we understood here, we installed all the packages and we loaded the modules, and please note we are using multi-prompt chain here, right? You can see the description here, a multi-route chain that uses an LLM router chain to choose amongst the prompts, right? So depending on the prompt, it will try to route, right? So here we are trying to load the environment variables. We read the key and we stored inside the API key, and then we initialized our OpenAI LLM, and here we created 3 templates. One is for the beginner template, expert template, and the empty template. Here you can define your own templates and replace here. So we have our templates. Next thing is we created a prompts list. The first one is for the empty template, and the second one is for the expert template, and the third one is for the beginner template. We created 3 prompts inside a list. And once we have the prompt list, we are using multi-prompt chain to bind the LLM prompts together, right? And inside the chain we have the function called invoke. So you do not have to define the routing logic like how we did before manually, right? Based on the question, the LLM is smart enough to understand the context and route accordingly and then give us the answer, right? So nowhere we have defined the logic, but the LLM understood the context and it was able to give us the right answer by identifying the correct prompt, right? If it is beginner physics, then you use this template. If it is advanced physics, then you use this template, right? So it routed accordingly and then gave us the answer. Okay, so now you get the idea, right? So you can replace these questions with any other questions, or you can replace these templates, right? According to your business need, you can try to define these templates and route them accordingly, and based on the question, the LLM will try to route to the correct one and then give us the right answer, right? So that is the objective of using LLM router chain. All right, thank you. So far we have seen different kinds of chains: single chain, sequential chain, MathChain, LangChain, router chain, LLM router chain, right? Now the next one is SQL chain, right? So let's go to our VS Code and see how we can implement this SQL chain, right? So this is our VS Code. Inside the chains demo, I'm trying to create a new Python file, and let's try to save this as SQL chain demo. And you know, the first thing is make sure you install LangChain OpenAI package. Once you install the package, the next thing is let's try to load all the required modules. We are using OpenAI as our LLM, so we'll be chatting with that. So that's why we imported chat OpenAI from LangChain OpenAI and create SQL query chain. This is from LangChain Chains. So this is the chain that we will be using, and SQL database I will explain, right? Now the first thing is let's try to load the environment variables from this .env file by using load_.env, right? And the next thing is let's try to read the API key and store it inside API key variable. And now let's try to assign this API key to the OpenAI API key environment variable, right? So once we have the key, now the next step is let's try to initialize our LLM by using this chat OpenAI, which is from LangChain OpenAI, right? And by using this SQL database, we have a sample database available for SQL Server, which is nothing but Chinook, right? So let's try to use this SQL database, which is from LangChain Community Utilities package. So we are using SQL database, and inside that we have a function called from URI, and we are passing the URI here, SQLite Chinook database, right? So we got our database, and now once we have our LLM and database, let's try to bind both the components by using this create SQL query chain from LangChain Chains. Okay, so for create SQL query chain, we are passing our LLM and the Chinook database, right? So inside the chain, we have a function called invoke, and let's try to pass the question. How many employees are there, right? So we are asking a question. So this create SQL query chain will create an SQL query from this NLP text, right? How many employees are there? For this question, it will give us a SQL query, right? So let's try to print the response and see what we have inside the response, right? So let's try to run this code. So now you can see select count of employee ID as number of employees from employees table, right? So it gave us a SQL query for this question. How many employees are there? Select count of this employee ID as number of employees from employees, right? So this is your SQL query. So once you get the SQL query, you try to create another chain, right? So first chain is we got the SQL query. You create another chain and try to execute this SQL query, right? So now you get the idea. So instead of just the select, you can try to replace the prompt for delete or insert or update, right? And then accordingly it will create the SQL queries and you can execute depending on your requirement, right? So what we have done here, we installed the required packages and we loaded the modules, we read the API key, and then we initialized our LLM, and then we got the Chinook database, which is a sample database available for SQL Server by using SQL database. Inside that we have the function called from URI and we passed that URI and we got the database. And then the next thing is we try to bind both LLM and database by using create SQL query chain, which is from LangChain Chains, and we got the chain. Inside that we have a function called invoke and we passed the question, and by using this create SQL query chain we got our SQL query, right? So that is how you can use SQL chain. So far we have seen different kinds of chains from LangChain Chains package, right? And by now I hope you got a pretty good understanding on how to initialize your LLMs and create the prompt, and how to use different kinds of chains, right? So if you want to deep dive more, there are many other chains available and you can explore more depending on your requirement, right? So this is the official LangChain Chains documentation. All right, thank you.